All right, so continuing on, let's look at this one. So I got the position function given here, and I want to find, and it's given in meters, and t is in seconds, and I'm looking at times that are bigger than 0. So I want to find the position when, it's not giving me a time, I have to go find the time when it is moving at 3 feet per second. So that means I need to set the velocity equal to 3. So 2t minus 3 is the derivative. Set that equal to 3. So I get time of 3 seconds. So that's the when. So to find the position, that's going to be s of 3. So that'll be 9 minus 9, 0. So it's at the origin when it's moving 3 feet per second. All right, so here's another one. How fast? So find the velocity. Is it moving when? Again, I get to go find the time. It's 10 feet from the origin. So that means I'm setting the position equal to 10. So that means I'm solving this quadratic. So I get t minus 5, t plus 2. So I get t is 5 and negative 2. So again, since I'm only dealing with positive times, I'm going to rule that out. So this is my time. So how fast is it moving? So again, I want to use my velocity function and put the time of 5 in. So I get 10 minus 3 of 7 feet per meters per second. Meters per second. All right, so let's look at this one. So I've got, let's get rid of that criteria for a minute. Let's look at it because I want to talk about negative time. So here I've got this position function. It's the same one. So let's go find the position at all these different times. So, and then let's graph them. So s of 0 times 0 is 0. Okay, so what I want to get to an idea of getting to know the number line. So this 0 is this 0. So to identify the time of 0, to put the point there, I need to put t equals 0 above it. All right, let's go find out where it's at time 1. So time 1, put 1 into here, I get 1 minus 3. So that gives me negative 2. So negative 2 is on the ruler, and I want to identify this time of 1. I would have to label the point. So when I don't have an XY axis, I have to do something else to delineate the time. Okay, let's do it again. So here I have s of negative 2. So 0's time can be a marker, and negative time could be before, and positive time could be after. So that's what that's meaning. So I would get 4 plus 6 or 10. So this would be here on the axis on the ruler, and this time of negative 2, I would just have to label it t equal negative 2. All right, one more. So s of 4. So I'd get 16 minus 12 or 4. So this 4 would be on the axis here. And then this time of 4 I would have to label. All right, so that gives you an idea of things that are happening as it's moving around. So if I was to kind of look from how time moved, so here it was at time negative 2. And then that was at time 0, and then time 1, and then time 4. So it gives you an indication of how the particle's moving, but we're going to find more detailed when we find out when the velocity is 0. So that's when the particle's at rest. And that's going to be when it changes direction, because I'm just kind of guessing as to how time flowed there. But I'm going to find the times when the particle is at rest. So let's find the derivative. So I get 2t minus 3, setting that equal to 0. So I get 3 halves. So that's the time, there's just one in this case, the time that the particle is at rest. All right, so now let's go find the position of the particle when the velocity is 0. So that means, I'm going to be putting into my position function my 3 halves. So I'm going to have 3 halves squared minus 3 times 3 halves. So I get 9/4 minus 9 halves. So that gives me 9/4 minus 18/4. So negative 9/4. Okay. So let's go sketch this particle over this time interval. And I've given some so anyway, so let's go find out where it's at time 0. So at time 0, I know it was at 0, right? Because we figured that out up here. So there's the position. So that we figured out where it was at time 3/2. It was at -9 force. Oops. Yeah, -9 force. And now I want to find out where it's at time 5. So it'll be 25 minus 15, so that'll be at 10. So let's go draw these. Remember, these blue underlined ones, those are the ruler markers. So there's 0, there's -9 force, and here's 10. So I need to identify the times, right? So time at the when it's at the point 10, it's time 5. And this time would be 3/2, and this time would be 0. So from knowing that this is the place where the velocity is 0, it starts here at time 0, moves to time 3/2, and then moves up to the place of time 5. So that's the path of the particle. We're drawing the y-axis as the ruler on the ground. So now, to find the distance covered, so I want to find the footsteps that are covered, I need to count the distance. So this distance from here to here is 9 force. This distance from here to here is another 9 force. And then this distance from here to here is a 10. So 10 plus 18 force, or 10 plus 9/2. That's a fine answer. So that's the distance covered on that time interval 0 to 5.